What affects depth of field? There are three factors that have a direct relationship with depth of field. Number one, aperture, and that's that diaphragm opening of the lens. Number two is the focal length. So it's the focal length of the lens that's in use. And then the image size and that direct relation to distance. We know that the smaller the aperture, the deeper the depth of field. So that happens and the lens focal length and the shooting distance remain the same. So these kind of are all intertwined. Now if you take a shorter focal length, a shorter lens focal length, you'll get a deeper depth of field, and that's if the aperture and the shooting distance remain the same. And if you have a greater shooting distance, the depth of field will be deeper, and that's if the aperture and focal length remain the same. So you can see how they are all intertwined. Let's take a look at each criteria here in a little bit more detail. Starting with aperture. So aperture is the size of the opening that allows light to go through the lens. It's expressed in f-stops. Sometimes it's referred to as f-values or aperture value, and the typical range is somewhere around f2.8, which is fairly large, to, most cameras go to f8 at least. Some can go much, much, much smaller. So when you look at that relationship again, a small f value or a small f-stop indicates a large aperture, and a large f value indicates a small aperture. So I always say to think of it as a fraction. So instead of an f2.8, think of 1/2 or 1 over 2.8. Or instead of an f8, think of it as 1/8. So obviously 1/2 is larger than 1/8. So just remember that the smaller the f value, the larger the aperture. Now if we have a large aperture, then we have a shallow depth of field. If we have a small aperture, then we have a great depth of field. Let's take a look at a graphic here to show that. So in this case you can see the aperture size. In this graphic, I apologize for the quality, but you can see the top is an example of 2.8. So the aperture there it looks as though it's wide open, and our depth of field is fairly shallow. If you look at the areas between the arrows, that's the indicated area that's in clear focus. If you look at a smaller aperture like an f8, you have a greater depth of field or a deeper depth of field. So if we look at a chart here, there's a little rule of thumb for selecting the right aperture for the desired depth of field. So rule of thumb, if we want to take the same object distance and object size and then do a comparison here, the bigger the lens opening or the aperture that's used, like an f2.8, it will have a narrower band of depth of field. The larger aperture, which is that zone of sharpness, it can be very limiting. So large aperture, looking at 2.8, less depth of field, that means very small depth of field, very great for portraits. f8 then shows a smaller aperture opening, which gives us a larger depth of field, and this would be great for landscapes. So if the extended depth of field is required, you want to choose a smaller lens opening like f8, f22. Some cameras can go pretty small. So when you do that, then you're making that sharpness be extended, so everything will be in sharp focus. Once again, one more graphic here. So if I look at some examples, if you want the subject that the lens focuses on to be sharp, everything else will be out of focus, and then you'd want to call it opening up the aperture or using a large aperture. If you need most of your picture to be in sharp focus, you would what's called stop down the aperture and gives a small aperture. So in this example, The one on the left has a large aperture, f3.5, and it throws the flowers in the background out of focus. The focus has to be precise. On the example on the right, it's using a smaller aperture, and so it extends that depth of field from the foreground all the way to the background, making it look as though almost everything, or a larger area at least, is in focus. And that was using an f11. So on the left is an f3.5, on the right is an f11. So a couple of things to think about. The portrait scene mode equals a larger aperture, shallow depth of field. Landscape scene mode is a smaller aperture, which equals a greater depth of field. In a lot of consumer digital cameras, you might not be able to control directly the aperture setting, and that's when you're going to look at your portrait mode and your landscape mode. So it can be difficult to obtain a shallow depth of field with a lot of consumer digital cameras, and that's because of focal length, and that's our limitation. But let's take a look at some other ways that we can play with depth of field. That is the distance from the subject. So when you focus on a subject that's close to the camera, the depth of field is less than when you focus on a subject that's further away from the camera. And so you step away from your subject to obtain a greater depth of field, or you move in closer to decrease the depth of field. And so that's some of the ways that those of you without a lot of control of your aperture can play with depth of field. Here's another example. So moving in close versus stepping away. Like we mentioned, when you step away from your subject, you obtain a greater depth of field. When you move in closer, you decrease that depth of field. So we're talking about the distance that we are. So in this case, moving in close, even though we use a small focal length, 35 millimeter, and a small aperture, an f7, by moving in close using macro, we are able to isolate the subject from the background. If we had used a larger aperture, would have obtained even a more shallow depth of field. So we've talked about aperture, we've talked about distance, and now let's talk about focal length. So when we're talking about focal length, wide angle lenses have greater depth of field. Long focal lengths achieve a shallow depth of field. So focal length, one of the times it would really come into play is with product shots, where you want to situate your subject in his or her environment, and you want both the subject and the background to be in sharp focus. So say you're going to set your subject in front of a tree or a bush, and somewhere 3 meters or more in front of it. If you use a wide angle and take the photo, both the subject and the bush would probably be in focus. Now, if you zoom in and you fill the screen or your LCD with your subject and then you take the photo, the background, whatever it is, the tree, the bush, will appear out of focus. And so then the background doesn't steal the attention from the subject. Wide angle lenses have greater depth of field than telephoto lenses. Those of you with a DSLR that have the ability to swap out your lens will know this. Most consumer digital cameras have very short focal lenses, and that's why it's difficult to obtain a really shallow depth of field. So some of you are going to struggle trying to get a very narrow, short depth of field. Again, there's ways that you can play with it though. A long lens also provides a flattened perspective, which makes the narrow depth of field much more prominent than just walking closer to the subject and using a lens with a normal focal length. So if we look at focal length examples here, here's a long focal length. So this was 380 millimeters. That means that they were able to throw that background out really nicely. Now if we look at this example, moving in closer, so it's still it's 112 millimeters, but they moved in close. So it's really thrown that grass out in the background to just a solid green color. So play with your aperture if you've got a portrait or landscape mode. Play with the distance that you are from your subject, and play with that focal length if you have that capability.